All right, today we are talking about functions, and here's our objective that we're knocking out. Students will be able to interpret and evaluate functions that are represented in various ways. So yesterday we worked on equations. Now we're talking about the general idea of functions. And functions, generally speaking, um, and we can start getting this down in our note sheets, they're going to relate an input to an output. If I put something into my function, like this yellow ball here, okay, I'm going to get something different out of my function, like this blue ball here. All right. These can be a variety of things. We might have the one example we talked about a lot in class was working. If I input my hours worked, okay, and this function is our job here, then the output that I'm going to get is money from that job, right? My earnings or my salary. Um, So mathematically, functions are just different ways to represent those inputs and outputs. A couple of other things that we want to jot down as definitions, and we won't use these a lot today, but I want to make sure we are aware of what they talk about. A domain means all of our possible inputs, while a range is meaning all of our possible outputs. Want to get this in front of us for later units, so we have at least a rough idea of what we're talking about there. Now, one way that we can represent a function is using function notation. Um, this will have this weird little thing where we have a function name f, we have some parentheses, we have an input x, close that parentheses, and then we'll have some equation that it's equal to. So on your note sheet, jot down this little diagram here, including these different names, all right? Our function name is going to be our output, our input is going to be x, and what we output or that relationship is going to be whatever that equation is equal to. Now, sometimes the function won't have a name. In this case, we'll often use y or some other variable. So if we take this same example that we had up here, instead of that f of x, we might have y equals x squared. In this case, we still kind of have the same structure where y is our output. We just don't have a function name. This x squared is what we output, or what to output. And all the meanwhile, this x here, even though we don't have it written, x is the input. So let's see how this plays out in some example problems where we're asked to evaluate different functions. For each function, evaluate the function for inputs of x equals 2 and x equals 5. So we have three different functions here, one for each example. And we're going to evaluate two different outputs based on the inputs we're given. So in example 1, if I'm given x equals 2, all I want to do is evaluate this function at x equals 2. I'm going to rewrite this function as f of 2. Notice how that x swapped out with 2. That's equal to 2 plus 3. You'll notice that everything stayed exactly the same except for that 2 and that 2 where we substituted the x out. If we evaluate that, then we're going to get f of 2 equals 2 plus 3 is just simply 5, and that's our answer there. If we want to figure out what's going on with x equals 5, we just repeat that same process, but plug in 5 instead. So f of 5 equals 5 plus 3. We swapped out x with 5, and so that just gives us 8. So f of 5 equals 8. In these cases, our input was 2, and our output was 5. And then on our second example, our input was 5, and our output was 8. So this can work in example G as well. If you're watching this video, pause your screen, work through it, unpause it as you go to check your work. So I'm going to plug in my equation here. G of 2 equals negative 2 times 2 plus 4. If I work that through, I'll get negative 4 plus 4. And so my G of 2, my function at 2, my output at 2 is equal to 0. All right, and my second one, my G at 5, is equal to negative 2 times 5 plus 4. This will be equal to negative 10 plus 4. And so if I rewrite this, finally, our function at 5 is going to be equal to negative 6. Lastly, this is an example where we don't have a function name. Notice how the y here doesn't have a function name. It still has an out. It's still going to be our output. That's still what we're calculating. We just kind of got to maybe make some notes to keep our work a little cleaner. So for x equals 2 here, I'm going to plug that in. We get y equals 2 squared minus 7. And if I do that calculation, I'll get y equals 4 minus 7, so y equals negative 3. Same thing can be done where x equals 5. If we calculate this at x equals 5, we get y equals 5 squared minus 7, which if you work out, we'll have 25 minus 7, and so our y value is going to be equal to 18 there. Another way we're commonly going to represent our functions throughout this class is using tables. And tables is just a way to, hey, we took an equation, now we're just going through and summarizing some data. So we could have actually started building tables with all of these functions in 1, 2, and 3, but oftentimes we're given that data that we can use. So if we're asked to evaluate f of x in this table below for x equals 4, and x equals 14. Let's start with x equals 4. All we got to do is find our x value here, find that x equals 4, and then so our output here is going to be 99. So at our function at an input of 4 is equal to 99. And then if we're trying to find it when x equals 14, all we got to do is find that x value of 14. That tells us that our output is negative 8. So our function at 14 is equal to negative 8. Same thing can be done for vertical tables. Just notice that our headers are listed a little differently. On our horizontal table, we had x and f of x on the left. At our vertical table, x and y are up top. There's no function name. It's just our output y here. So we're finding it for x equals 0 and x equals negative 3. At x equals 0, I just go down, I find x equals 0, I look at what that output is there, and so I have, we have an y equals negative 6 for x equals 0. I'm going to make some arrows to make sure that's nice and clear. And at x equals negative 3, I find my x equals negative 3, and we get y equals negative 33, and this happens when our x is equal to negative 3. All right, the final way that we're going to represent our functions throughout this class is using graphs. When we have our graph, our input is always thrown on the x-axis, our output is always on the y-axis. So if I quick do a reminder of what this looks like, our x-axis is going to be our horizontal, so that's our side to side, and our y-axis, our green, is going to be vertical, so that is up and down. So if I'm trying to find this first example here, let's do this one in orange. My function at 2. I'm going to find out where my x value equals 2. So I go over 1 step, 2 step over here. Here's where my x value is 2. And if I trace down, I'll notice that, hey, my height of my graph is at negative 2 here. And so the value of my function, the height of my function, the output of that function is negative 2. This next one I'll do in red at f of negative 4. So our input is negative 4. I'm going to go over 1, 2, 3, 4 spots. I'm going to find my function. The height is up here. It looks like it's at, if I count over, it is at a height of 2, positive 2 this time. So my function at negative 4 is positive 2. And lastly, I'll do this in purple. If we look at our x value of 0, I actually have no height on my graph. Notice how I'm just sitting at the origin there. So my output at 0 is simply going to be 0.